I think it's best to sort of get into this activity. So what we're going to do today is we're going to do a short little demonstration of a little homemade activity using basic household ingredients on how to basically recreate what it is space collisions would look like. And I'm talking about impact events or impact craters. So this is the reason we're doing this in a lunar session is because if you are to take a look at the moon, which many of you will in the next hour when we get into the RASC activity, we are going to, you're going to notice that one of the most prominent features on the moon is craters. So impact craters formed by the collision of many asteroids and small bodies over time, impacting the moon and leaving these sort of little impact craters on the area. So we're going to get started on how you can sort of recreate that at home using some simple household activities. So I'm going to get us started on that. So the first thing you're going to need is some sort of thin, this is a little thicker than you need, but some sort of pan in which to conduct your little recipe here. So you have this pan here. You're going to need flour. You're going to need a little bit of cocoa powder for later. And we're going to have our impactors, of course, of different sizes. You can use whatever you have that's like golf ball size or small that you got lying around, something that you really think could make as a good impactor. I've got a bouncy ball here, a ping pong ball, a marble. If you have more than one, that's actually really ideal, especially if they're of like different types of things. If you have like, you know, a wide variety of potential impactors, that's ideal because we really want to see how this all sort of comes together. So starting off on the first step of this activity, we've got our pan. You could ideally go for something a little thinner than this. As long as you've got something to hold it all together, you take your flour and you start to fill up the pan here. And you want it in such a way that, shake it around so it's more or less even. You want to have as much of an even surface as you can. And try and not have it be too lumpy, but you know, you take what you can with that option, I suppose. But you want to essentially have it more or less laying flat and covering roughly about an inch of, be roughly an inch deep. So you want a good amount of thickness to the thing that you got going on there. Hello, you joining on?
Hello.
Perfect. Perfect. So you're going to follow along with the activity, or are you just going to watch?
I'll watch. I don't really have the material.
Oh, yeah, no worries. If I have time at the end of the session, I'm going to probably link people to a website where they can sort of test out the same general concepts virtually.
Mm-hmm.
So that's going to be an exciting another opportunity, and I absolutely encourage anybody who wants to explore this on their own time to do that as well. But for now, I'm going to do the household activity that we got going on here. So we've got our little recipe here, got our aluminum pan, and we've got our flour. Now, once you've got it more or less as a flat surface, I'm pretty sure mine's flat, but I'm going to be a perfectionist about it. The next thing we want to do is, okay, so you see that we have it here. So next, what we're going to do is we're going to take our cocoa powder, and ideally, if you have some kind of tea strainer or something like this that you can sort of help strain it out, like with this sort of thin mesh coating. It doesn't necessarily have to be something big like this, but if you have some semblance of like a strainer like that could sort of make things easy, to make it easier for pouring the cocoa powder, then that would be ideal, because what we really want you to do is you have your thick base of like just a thick coating of flour there. What we want you to do next is you take this, you put the cocoa powder in the strainer, and it can be a little, but you basically, as best you can, you want to just keep coming at the cocoa powder. You want to spread it around so that the cocoa powder roughly forms a thin layer over top of all the flour. So I'm going to, it's a little straining right now, but I will make the best effort I can. Okay. So if we go like this, we can spread it around a little more easily. There we go. All right. So that's coming along nicely. You got any questions or anything in the chat, just let me know. one of us here will try and help to answer that for you. But I think once we get, I just sand down the edges here, what we would have is essentially the cocoa powder sort of forms our topsoil, I guess. It's just the very thin layer over the top of the flour. So at the end of the day, you have a base. This is going to be your lunar soil. This is going to be your surface of the moon. That's the sort of, you could think of the cocoa powder as something like the regolith, I think is a term it's called. The dust, the fine dust that's on top of the moon's surface. And you can think of the flour underneath as sort of the rock below it. So I think that's sort of an interesting way of looking at it. So once you have that, your regolith in the form of cocoa powder evenly spread out as best you can, and once you have your flour down and everything, next thing you want to do is you want to do your drop. You want to take your impactors of different sizes. Again, you can use whatever you like. I happen to have a few different sizes here: tennis ball, bouncy ball, and marble. So I think first way to, and then once we have this, you want to get it roughly a foot or so above the surface of your moon. And once you have it like a good enough height where it could get a lot of gravity behind it, when you feel comfortable with it, you just want to take it like this and do your drop. So let me examine this. Let me take the tennis ball out because asteroids tend to disintegrate on impact. But let's see if we can get a good look at, okay, yeah. So you see, what you're kind of noticing here is that there's this big, I don't know how well you can see that on this camera, but there's this sort of big, like sort of roundish hole in the middle of our lunar surface. And you notice there's a little bit of, it's mostly just in the cocoa powder, but there's a little bit of flour that peaks to the surface too, roughly where the impact hit. So you can think of that as like an asteroid coming down onto the moon's surface is going to collide with it, and it's going to eject things everywhere. It's going to eject regolith and rock everywhere. It's going to form this sort of ejected area. And so the center of the, you're not going to see that at the impact site. You're going to see that because the impact site is just going to fill in with the dust and stuff that got kicked up. But you'll see the area around it. Some of the stuff inside the moon below the regolith gets kicked up, and that's why you see flour when you do the drop. Now, that's kind of a wide, I chose to do the tennis ball one because the tennis ball, this is kind of wider and also kind of like pretty light, all things considered. So what happens if we do basically the opposite of this? What if we did something that was narrower, but also a fair bit heavier? So that's why I have this marble here. This little marble here, it's considerably heavier than the tennis ball, but it's only just a little bit as light. So before I do the drop, I want everyone to see if they can take their guesses on how this would be similar to the tennis ball crater versus how people think this might be different. But at any rate, I have my marble here, and I'm going to hold it up like this, safely above the zone of impact, and then drop. All right, okay. I'm not sure how well you can see this, but that left a very fine impact crater, and I'm just going to see how well I can show that to you there. Oop. This keyboard is not really necessary. All right. So let's see here. I don't know. Oh. Okay. Let me just try. Oh, yeah. Okay. So you can see over here, that was the little sort of impact left by the tennis ball. And you have our big, heavy marble. And you can see a nice, solid crater with sort of left a very deep impact on our surface. And all around the area, there is flour that has been kicked up from beneath the cocoa powder and ejected outwards. And you can really see those patterns of sort of ejected material coming out from below the regolith and forming this sort of splatter pattern, I guess to say, for lack of a better word. And you got to think about how that might be different from the tennis ball. For one thing, yes, the tennis ball is more spread out and it's a lot lighter. So it left a very little impact, a wide impact, but it was very shallow impact, like the crater created by the tennis ball was wider, but it was very shallow, so it didn't get very down deep, and you only saw a little bit of flour underneath get picked up. Whereas, as we can see, with this very clear impact crater, flour kicked up in massive ridges all around it, and flour sort of strewn out below it as sort of that ejecta pattern. And you got to think that's probably so. When you look at craters on the moon, you're going to see both of these different types of craters. You're going to see the shallower ones where not a whole lot is kicked up, and you're going to see these really deep ones where you see this whole ejecta pattern scattered about everywhere. Now, the reason for that is because if you know anything about asteroids or comets or anything of that sort, you know that they're not all really the same. You have things like rubble piles, where it's just a loose collection of sand and dirt. You have like much harder rocks built out of like very fine refined metals. So asteroids are going to come in different, much like these impactors, asteroids are going to come in different weights, masses, sizes, all these sorts of things, and composition. So you can tell, I think when you look at the craters on the moon, you might be able to identify what was a perhaps heavier rock that impacted that area versus what was a perhaps more narrow area that impacted that area. But one other sort of factor I want you to take in is what happens when it's not just a straight drop. And this is what I've been saving the bouncy ball for. What if instead of a straight drop down clear onto the surface, you had it come in at an angle like this, and maybe you had it go quite a bit faster than the other things. And this is really where the fun's going to begin with that. So I'm going to take this bouncy ball that I got here. I'm going to hold it up like this, and I'm just going to kind of throw it down there, and then we're going to see what happens. Whoa, okay. Okay, so you can see now the bouncy ball, I should say, texture-wise, is both wide like the tennis ball and heavy like the marble. So it's kind of a perfect storm of impact craters. But let's look at that one. That is probably the biggest impact crater we created today. So you see, big hole right in the middle. A bunch of flour has been kicked up around it, and there's ejecta patterns all over the other area, outwards like that. And you notice that instead of being like, I don't know how well you can see that from here, but instead of the ejecta all being in a nice little circle, those little splatter patterns that you saw, instead of being in a nice little circle like we saw with the marble, the ejecta patterns all seem to go in this one direction, and it is the direction opposite from what the angle that the marble or the bouncy ball came in. So it came in at an angle like this, and all the ejecta patterns get blown out that way by the force of everything. So these are a few of the examples of the types of things that you would see with a lunar crater. And I think if you want to test this out with as many impactors as you can change speeds, you can change angles, you can see what you can create with that. I just destroyed our tennis ball's crater with a new marble crater. But yeah, you can see very similar thing like that. So this is really a good sort of way of demonstrating what it really looks like when an asteroid collides with the surface, like what we see on the moon. And from that, you really get a sense of like, you should probably, from what you take away from this, you should ask yourselves, how does changing your projectile, how does changing the type of impactor you send change the shape of the crater? How does changing the angle change the shape of the crater? What's the difference between a straight drop and a angle drop? Also think about changing the speed. What if you just kind of whipped one at there? You get more of like a dramatic sort of splash there. But this is just sort of an example. And if you have flour and cocoa powder and a tea strainer and just very simple things like this lying around, you are more than, Ohm asked a very good question. So would the heat or temperature of the rock also impact the collision? So the heat and temperature would leave an effect. That entirely depends on, yes, that would be related to the speed that the rock comes in with generally, because there'll be at different temperatures in their orbit around the sun, but when you are having something come in at a really rapid speed, that's going to this was more relevant for Earth, but when it comes into the atmosphere, that's going to heat it up a lot more. But yes, depending on the heat or temperature of the rock, there would be a noticeable effect. And if you don't necessarily have these household items that I have here today, you are more than welcome to sort of ask yourself all these same questions in a virtual setting. I'm going to post a link to a online resource that I think is very useful in terms of answering these same questions. So I'm going to drop this into the chat here. So this is the down-to-earth impact calculator by the I believe the European Space Agency. So what you can essentially do with this, and I can't share my screen right now, otherwise I would do a more proper demonstration, but what you can do with this is you can choose one of three sites, either Earth, the moon, like we're doing today, or Mars, and you can essentially create your own impactor, whether it's like an asteroid or a comet or something like that, and you can essentially make that impactor however you want it to be. You can make it go in fast. You could make it like come in at an angle or come in straight on. You could make it looser or more solid and sturdy. You can change all these effects with it, and then you can change the size of it as well to see how big of an impact you want to make. And then what you essentially do is once you've put in all your components and created your impactor, you launch it, and it will show you exactly how big of an impact crater you will create on the planet you have chosen to destroy. The size of the crater, the relative sort of damage and destruction. If you were to do it on the Earth, you could see whether or not you could destroy a city with it. If you could do it on the moon, you could see if you could create a crater big enough to overpower the biggest ones that we know of. So absolutely try this little online exercise activity you've got going on here. But if you don't have those materials on hand for yourself right now, I would absolutely recommend that you check out that website and you sort of play around with those little ideas as best you can. With that, I think I am coming to the end of my time here. Yeah, I'm just hitting 7:35, so that's been the 20 minutes for us. I suppose if anyone has any questions, you can pop that into the chat. Otherwise, I'm going to give it a couple minutes, and then I think I will bring this particular session to an end. And if you have any like follow-ups about myself or my organization into space, I'm going to be at the booth that we are running right now, and we are going to and we're all happy to answer any questions there. And otherwise, we'll reconvene at 8 o'clock for the observations of the moon. So just giving that some time. Don't know if anyone has any questions. Just trying to see what information I can glean here. All right. Just got the chat here. Alrighty. No worries. So I don't necessarily see any more questions coming in. If that's the case, I hope this session's been an exciting one for you. I absolutely recommend testing this little exercise out because it's a lot of fun, and you actually really do get to learn by doing when it comes to sort of understanding how moon craters take shape, or craters, I guess, on any planet like that, any planet or moon like that. So absolutely check this out on your own time. Feel free to check out that website I've dropped for you. Otherwise, thank you guys so much for coming out and checking out this little demonstration I'm putting on. I'll be in the Into Space booth from now until 8 o'clock. And otherwise, we will all reconvene on the stage at 8 p.m. for the RASC's lunar observation time. All right. Thank you so much. Have a great night.